Can an Arduino and mass forest fire destruction? That is the question of the day. By JK. What is an Arduino? An Arduino is a microcontroller. Well, the certain Arduino I use is called an Arduino Uno R3, which is a microcontroller. This means that it is a small computer and it is able to allow the code that is run from the code video device that it runs a code to make lights, sensors, buzzers, and monitors do whatever the code is programmed to do. What is the project and what does it look like? So my project is an Arduino connected to a breadboard that can send smoke. And the other part of my project is a solar panel and a light. And this is not my research, this is just a project that I did to create. So this is what it looks like. These are the two LED lights. This is, of course, the Arduino that runs the code through. This is the buzzer that makes a noise. These are resistors, these things. The wires you see, these are just simple jumper wires that allow electricity to run through to the electricity and code to run through to wherever it is pointed at. And this is an MQT sensor, which is what senses the smoke. This is a solar panel that the rays go through, reaches, and it comes to the light. The positive charge from this end goes to the positive side, which is the red side. The negative charge, which is the negative, goes to the negative side, and of course the positive and negatives on the light bulb. And you gotta put that in. And so now, what were you researching? So what I was researching was what was the best threshold, or threshold is the amount of smoke required for the buzzer to go off. So what was the best threshold? I wanted to know what would make it easiest for the firefighters, because at the end of the day, they're the one fighting the fires. The second thing that I wanted to research was, is it possible to use a solar panel to power my project? Now, what were your findings of your project? I found out that the best threshold was 50, because it made it easiest for the firefighters to detect fire. It didn't go off when no smoke was there, or just a very small amount of smoke that was so little that it could have been anything. But it did go off when there was a large enough amount of smoke detected, which is maybe a simple fire. Like maybe a simple fire they checked and they can just check it out. It also found out, and that of course would be if it was close. If it was really far, then there was no point in a low fire. There'd be a big fire for it to detect from far enough. It also found out that the solar panel was not large enough. I also found out I found out that it was not available, that the solar panel was not large enough to power the whole project. So they want to see, can we see your project in action? So yes, you may. So I'm gonna just play it in Drive. So give me 1 second. Sorry, there's like really weird technical issues. I'm gonna just go to Drive itself right here. So I'm gonna just do it itself here. So this is of course the MQT center, and this is it. So as you can hear, once the smoke is detected, it goes off. And this was a very high threshold, which is why it took quite a while and quite an amount of smoke for it to detect. And that's the buzzer going off and the light switch. So when it's detected, and of course this is a mini version of the project would be much bigger, because at least the noise would be much bigger, because look at it in its size. This is the breadboard compared to my hand. So yeah. So now we're gonna go back to the slides. So we can go here. So yeah. So now, can you show us one of your graphs and explain them? So yes, of course. This is my graph. Of course, I use Desmos. So this was a table which shows the x-axis shows the threshold, and the y-axis shows the amount of seconds it took per detection. So the x-axis, it goes 0, 50, 25, 100, 125, 150, 175, 200, which is the maximum threshold for me was 200 because it took too long after that. And the maximum time for detection was, of course, with 200 to 10.25 seconds, and what I said was the best 50 to 1.17 seconds, which is a good enough amount, which is a good amount of time for people in the area to know. What do you think can you do? What can you do to improve your project? Now, of course, just creating a project is good and all, but you want to improve on it. So we can introduce a whole new method in putting a drone, is using a drone as a carrier and also a camera to view where the fire is. This can happen if you can code the drone at a certain point of day, just like maybe a Roomba that can be just you press a button and the Roomba goes out and cleans your house. You can do that as with a fire. You can set the drone out and the drone can go around the fire at a low enough altitude but not low enough for it to hit a tree, and you can see if it senses a fire. You can also code the drone so that if the moment a fire is detected, it notifies you and you are able to view on a camera, which many drones have. This can create a totally new technology that I don't believe is out there, making the fire sensor a lot more effective. And for the solar panel, all you really have to do is get a larger solar panel which can absorb more heat, because for this, the solar panel was not large enough, which caused it not to create the whole project. So, what materials were used? An Arduino, some resistors, some breadboard wires, some jumper wires, some LED lights, a buzzer, a breadboard, electronic testing. Though this was a breadboard. This is an MPU sensor. I used paper to light it, a lighter, some solar panels, and yeah. So thanks for listening.